Hi, folks. We're going to take a look at our next couple of slides today in engine components. So one of the first things we're going to talk about today is some common piston problems. Most of the problems that we're going to look at are caused by a lack of oil, where the engine gets too hot and the parts either warp or they break, or we get carbon buildup, which is not necessarily from not enough oil, but just can be from general usage over time. Okay, so one common piston problem is called warping, and this can result in engine knocking or engine slap. Basically, the piston can get out of round within the cylinder. You can see up top here the pictures with the A and the B. Basically, on the left there, A, we have the piston has warped out in the left and right directions. Either that's going to create excessive force on the outside, which could cause the piston to seize, or scratch up or score the cylinder and possibly get stuck. Or we may actually get a situation where the piston in the other direction, up and down, is too loose, and the piston is going to basically it's going to bounce against the wall inside the cylinder because it's not tight enough within there. This is going to either cause a compression loss and very quickly will probably result in a broken part. Okay. So another common problem that we will come across is that the piston rings can get worn down over time. Again, this is generally caused when we have a lack of oil and the engine starts getting too hot, and those parts will start to overheat and either break or they will wear down over time. If they're worn just in general, this usually will result in some kind of a compression loss. So the engine may run, but it's going to lose power, or when you try to do a high power application like mowing some wet grass or something like that, that it's going to really bog down and it's going to stall out. And that usually just means that it can't hold that higher compression when you call for it. Okay. So the worn rings can also result in piston slap. You can often hear this. It'll be like a ticking noise when the engine runs, tick, 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 really fast. As many times as the piston is moving around in the cylinder there, you can just kind of hear that slight tapping against the cylinder wall. It definitely will get louder over time if it's not fixed, and again, will probably result in some broken parts. So one way to check whether or not the piston rings are worn down is to measure something called ring end gap, and we'll actually be doing this in class when we do our engine inspection. So you'll actually need to place the piston ring, once you have it off of the piston head, we'll put it back into the cylinder. You'll kind of nestle it in there and keep it as flat as you can. And then you can see down here, using a feeler gauge, we will measure the gap. Okay, if the gap is too big, that's a bad thing, because that means that we have too much compression is going to be sneaking out or leaking out between that gap, or that means the ring is not going to have enough pressure against the cylinder walls. Too small of a ring end gap is also bad. That usually means we have either debris built up on the piston lands, and that can cause that ring to break. If all of a sudden it starts touching and there's too much force on it, it's going to snap right inside of the piston, or inside the cylinder, rather. Okay. All right, so let's talk about the camshaft and valves here. All right, so the camshaft is this part right here in the top left picture. The cams are actually these two kind of teardrop-shaped lobes. A cam is actually a mechanical device. They come in different types of shapes, but the ones that we find in engines are teardrop shaped. And if you look at the picture down below that one, you can actually see the cam in three different positions there, to the left, straight up, and down. And basically what happens is as this crankshaft turns, the cam position is going to rotate. And you can see when the cam is pointing straight up, it's actually going to open up the valve. It really pushes on the bottom of the valve. And it overcomes the pressure of the spring, which we can see in the top right picture here, and it's going to crack that thing open a specific amount, and that's going to either allow fuel to come into the cylinder or exhaust to flow out. Okay. There are some problems associated with when this valve does not open enough or does not close all the way. We'll talk about that later in class, but essentially this is the job of the camshaft, just to kind of open the valves. Notice too on the top left picture there that the cams are facing different directions. One of these cams controls the exhaust valve, and the other one controls the intake valve, and they are timed within the engine so that they coordinate with other functions, such as the position of the piston, the timing of the spark from the magneto and the spark plug, and along with the necessary valve opening as well. Okay. In the bottom right picture here, what we see are the timing marks that are required for reassembling the engine. So when we put the engine back together, we will need to line up these marks. Sorry about the bell. Otherwise, the engine timing will be off, meaning that the valves are not going to open up correctly at the correct time, which can be a problem. Even if these are just off one tooth, then the engine is going to skip. It may run, but it probably won't run well. And certainly if these are off by more than a few marks or you didn't pay attention at all, that the engine will definitely not run. Okay. One other extra tidbit of information that you see on the camshaft here is we actually have what's called a decompression mechanism. Anyone who has a dirt bike or a quad, you might actually have a manual decompression on yours. Sometimes somewhere underneath the seat area, there's like a little decompression lever. So basically, if you're trying to pull start or kick start your quad or your dirt bike and the compression is too high and you can't physically push down hard enough, you click the little decompression button. It basically opens up the exhaust valve just a little bit and it releases any pressure that's inside the cylinder, and then it makes it easier for you to step on the starter. Okay, same might be true if you're trying to pull start the engine. All of a sudden, sometimes you pull it and it yanks your hand back in because you tried to overcome the compression, but the compression won. Okay, and usually in a small engine, what we have is this little spring-loaded piece here is actually going to do just that for us. It's going to automatically, when the engine is at a slow speed, it's going to open up one of those valves just slightly so that there's no compression. So when we try to start this thing up, it's easy to pull. As soon as the engine starts spinning, this little spring-loaded arm here will kind of suck back in, and it will no longer push the valve open until the engine comes to a stop or is extremely slow.